Hello everyone. I thought a bit about how I'm going to implement rendering the text, and I think I'll go with the easy approach. I watched a little bit of SDF, and it sounds to be the idea is simple, but there is so many edge cases. And anyways, so I think currently the best approach would be to do it a traditional way, just with rasterizing font way. So I'm going to create a class font, right? Pragma assets. So this one is going to be let's look at the implementation of the mesh. I think I did as simple as possible. Yeah, so it should take path and assets. Would be nice to be able. It's like if you do not need assets, you do not need to specify it. Would be nice to figure out that way. String. So it should string. It should have deleted copy constructor. And it's not mesh, it's font. It will have a destructor, right? I'm kind of surprised mesh does not have destructor. So what kind of mesh name file path? I think it should take the size. Actually, I do need path assets because I want to generate the texture, right? So it's gonna be functional. It's quite bright here in my room. Alexa, turn off the lights. That's better. So we would have here texture, and it's gonna be reference wrapper, atlas. Hmm. Interesting. Oh, it does. It does. It is being derived. Okay, so clone base asset.hpp. So there is a hierarchy. What I don't like here is essentially path should fully specify the font. So its size cannot be part of the constructor because we can do lookups in the assets. Then this one is I guess sort of cached version, so it's gonna be unordered map. So it's gonna be int. So I want to have atlas not for every single size, but have it double every time, and then kind of what is it, scale down. So I think this would be way to manage the size. Unicode ranges. Unicode character ranges. unifies defines 346 blocks. Hey, enjoy. Assigned characters, so we can quickly scheme. So there is a 358, 640, 250, 640. I think I can order the table, right? Oh yeah. 142,000. Oh, Hangul. What type of font the vector font, I do not know exactly what did you mean. What type of font do I want to render? It just I want to implement a rendering text rendering system in my game, so I would be able to output the text, and not in the debug way, but like performant and in the way it's looking good. Like it's not for debug purposes, it's for production purposes. So currently I'm thinking how big Atlas is supposed to be, and I was thinking to break Atlas to different ranges, but ranges are quite big, so Atlas as well has to be very big, which is I don't want to have very big Atlas. There is a funny thing. There is ranges with 0 characters, and there is a range with 1 character only. What is this? List of supplements containing supplementary character of the Fraser alphabets, which used to write the Lisu language, is supplement to the main Lisu block, which currently only a single character used for Nahi language assigned to it. Four common, 5 common. Harigana. Cyrillic extended C. Interesting. What characters there is here? I don't know. It looks like a V. Oh, it's a V. Yeah, it's a D. O. Narrow O. S. Tall T. Doesn't look like T though. Small letter. Oh, this looks like T. Tвердый знак. Hard sign. Tall yat. Oh, yat? Yeah, yat is used to be part of the Cyrillic. Then they removed it. So ranges are quite big, what I learned. So there is a Hangul syllables. Is it Korean? Oh, they have all combinations. Oh my god. That's mad. No, it shows nothing. I don't know what to do. Maybe I'll do only ASCII for now. What pragma assets once? I'll do only ASCII for now. So we'll have UI pass class render. Do I want to GLM vector float rotation position float size? Void include GLM vec2 HPP stat string path so we would have constructor, deleted copy constructor, and we will have function called UI pass, which would take renderer, position, rotation, and size. Position, rotation, size, also color. Color. And text. String. Light mode is making me blind. Const text. No, it's a comment from the from YouTube. I'm streaming on YouTube and on Twitch. I do not know if it's going to show the.
Yeah.
No, it's a. Yeah, here we go. This is the comment from Blood. Hi, Blood. How you doing? Color, position, rotation, size, and text. Anyways, let's just figure out how to render it, right? So the idea is it will take the size and then figure out what kind of atlas to use from the size. So there is a texture, but also as well it requires some more information. It's not only texture. Why it's so complicated? Do we have existing solution? There is a some okay, let's see. So there is examples. Yeah, there is example font. So let's look at this example. Font manager, load font, loan, create ETF. Now let me first see what is it. Examples 10. Examples 10. Just found about this cool project. You are talking about my project, the quick brown fox jumps over. Okay, so I think it looks pretty good. So it's doing 120 FPS, no problem. There is no but I think okay. So multiple fonts. Let's see how it's implemented. Font path file. So there is a init. During the init, it's just loads the fonts. Create font but by pixel size. Create font by pixel size. preload glyphs. Preload glyphs and bleed them to Atlas. Okay. My people for some reason emailing. So let me switch as well to the streamer mode. It's a tradition for me to forget to switch to streamer, but so what email I've got? Oh, spam. Spam. Font files, preload glyphs and bleed them to Atlas. Preload glyphs. You can unload the TrueType files at this stage. So it did it for all different fonts and different sizes. Text buffer manager, setup style color, set pen position. Is static text buffer compatible with alpha font? Static text buffer content can be modified after this. Okay, let's look at the font manager. Where is it? Font manager. Create a texture cube with linear filtering. Retrieve the atlas. Invalid handle if the loading failed. So man, that's crazy. I'm wondering if I just because this code is sample code, but if I just can font manager, text buffer manager, text metrics, UTF-8, for details. Okay, so I'm making executive decision to take all this code and bring it to my code base. So not this. Um, okay. Now let me change underscore into the it says buffer is read only. Underscore into the dash. Then okay. Oh, fs as well. So because my build system take them in this format, and the reason why I choose this format, so if I order files alphabetically, they would be ordered nicely. So as we can see, text metrics. Yeah, so as we can see, so we have font UTF text font. Now I want to make them HPP. And hopefully it would compile, but it may not compile. Let's see. So it did not compile. Sampler cube. Sampler cube. Gel position view model view pro. Oh, okay. View model view proj. Varying. Font basic. There is a common shader. shader lib. I'm afraid I'm opening the can of worms. Vec4 A position to Vec4 constructor. I get. Oh my god. So the problem is with variant. And variant definition. Ooh, where is it? Where is it? Where is it? Here. A pose is taking the vector 2. A position takes vector 2. I guess let's copy it and call it font. Okay, and in the make file, I'm wondering, probably I should put it on front. Okay, now let me rename it's ugly kind of because there is a font, basic font FS. Not making me very happy, but I just want to make things work. And yeah, let's make things work first, and then we can make it pretty. Okay, so let's remove text metrics. File not found. What? Oh, right. Because of this, remove this. I think I would not do SDF implementation. So let's remove this. Cube atlas. Text metrics. Oh, it's HPP as well. String inflection kebab keys. Cube atlas. Feels like it's needed. Cube atlas.h. No name, no member name. round. Round. BX math. Bake leaf distance. Let's remove this thing. So I'm not going to do SDF. UTF-8 decon. Using declared identifier. UTF-8 decode. BX assert. BX macros. Do not include macros directly. Include BX. Yeah. UTF-8 accept. It's set to 0. UTF-8. Okay, let me do brute force search. This is super annoying. Then somebody put like a JSON. Just a one line. Where is underscore? There is underscore. basic bin. Embedded shader. Yeah, this is kind of going to be broken, but it's fine. Include space. So everything in that format. I guess I can search for like this maybe. Nothing. Okay. BGFX create program. Program, load program. Load program. Oh, that should be changed to load program. I guess I can remove that. Oh, stbtt init font. stb init font. Is it coming from third party? Do I have third party? In includes. I do not have third party in includes. Where it's picking it up? Yeah, it's picked it up from here. Okay. So what I need to do, stb true type impl.cpp include stb true type.h, and I need to put that thing here. Why this one is not happy? Oh, I made some typo, I guess, somewhere. Okay. Bake glyph distance should go interesting. There is still some implementation. I thought I deleted it. font type distance. What the heck is this? So I'm a bit confused. Let me undo stuff. Bake glyph distance. Okay, let's compile and true type font bake glyph distance. True type font, and it's here. Code point glyph info. Code point glyph info. True type font. To bake glyph distance. It's here. Oh. Okay. Font manager. So I was looking at the wrong file. Bake glyph distance. So let's remove it. So yeah, I removed bake glyph distance. Font type distance. So let's remove that thing. Okay. Distance. Things are compiled. So a lot of new files. So I want to see if I by accident modified anything here. Doesn't look like I did modify anything here by accident. Everything looks good. Okay. Shardly. Okay, let me take slight break. Okay. So I've got all of this stuff. And what next? guess the mantra make things work. Let's go to the main.cpp, and in the main let's see first if it's gonna run. Yeah, it does run. Okay, now let's look at the example font. PGFX examples font. And I need to pick the font. Let's pick this second one. So it's CHP fire. I'm going to move copy it to assets directory. Yeah. So let's look again. S font file path, load ttf, m font manager. Okay, main font manager. Font manager equals font manager. I do not know what it's include font manager.hpp font manager font text atlas texture side with create the font manager and create the texture cube with linear filtering. Okay. Okay, font manager and load ttf. Static. File path size. Mm-hmm. Guess there is a load mem. Load texture. I think I can do same thing. File. File path. And size equals content dot size. Content dot data. Yeah. Oh my god, I made modifications in the wrong file. Main. Include fstream. Entry get allocator. We do not need to do free. Okay, load TTF. Load TTF. Font file equals load TTF font manager, and path is assets. That one. No matching function. We need pointer. Screw it. Here we go. Okay, so I modified something, so probably, yeah, so need to revert everything. Reverted. Oh man, what just happened? Main load TTF and create font but pixel size. Okay. Load TTF, then font equals font manager, create font by pixel size, font file 032, preload glyphs, font manager, preload glyph, font. So let's take this. Destroy TTF. Font manager dot destroy TTF. Font file. Okay. Font manager, create font by pixel size, load TTF, create font, destroy TTF. Okay, what next? Text buffer manager. Text buffer manager. Text buffer manager equals text buffer manager font manager font manager include text buffer manager okay. Create text buffer. Create a static text buffer compatible with alpha font. A static text buffer content can be modified after it first submit. So let's create set pen position, append text, set background, set underline color, set overline color, set strike background, append text, append text. Append text, append text. Create a transparent buffer for real-time data. So this is all we need. Shut down and update. Clear text buffer, set pen position, append text. Submit text, submit the static text. M transient text, M static text. Create text buffer. Okay, I'm just going to copy paste. So there is a bunch of manipulations. So this is static text. Create text buffer static text. So what it's doing with static text? Set pen position, append text, background color. So it's doing a bunch of stuff with static text. I think let's try it. So let's do create text buffer static text, and then set pen position, okay, and then write some text, static text, font, okay, and now write some style text. Okay, there is a styling to strike outline. Okay, and what? And submit should happen in the loop, so let's do submit here and see what would happen. Did we crash? Not found. Font vs bin, font basic, font vs bin, not found. Make file. Font vs bin. Font vertex bin. Font vertex bin. Shaders. Oh, wait a second. Something not right. Oh, I see what's going on. So let's put here. Here we go. Still crashed. Ah, no, it's still loading. Did you see it? You're annoying, main. So what main and font.cpp. So what is in destructor? Huh? Shut down. Font manager dot destroy ttf font. True type font handler. Destroy font. Destroy font. Destroy text buffer. Destroy text buffer. Static text. Text buffer manager. Look at, there is a something in the distance. So there is some progress. So I need, there is update, okay, so I guess I'll just copy paste this part, put it here, include bx.hpp. Where is the, why it's not complaining? Ah. bx start.h bxmuff. So there is a text. but it's gray for some reason. Static text. Static text. Static set pen position. Overline, strike through. So there is a text, but okay, time for debugging now, right? Submit text buffer. Text buffer, submit. Font type alpha. Buffer static, vertex buffer handler, set vertex buffer, transient, and submit. It says blend source alpha. Set vertex buffer. Submit. Should work. So there is a basic program and font, basic font. What? Why render type? Load program. Load program. Load shader. Oh, get render type. Okay, so render type is OpenGL or DirectX and other stuff, right? So where is geometry coming? Vertex layout, begin position, text color. Oh, there is a bunch of things. VBX, IBH, VBH. Get vertex buffer. And vertex buffer. Oh yeah, and it's okay, so it's being generated set vertex append atlas face. Okay. I guess I'll try to ask Gemini, endless drive, Gemini. I am trying to implement text rendering, and I have some sample program in the main, and it's drawing the text, but it's as well puts gray background. And can you help me to find out why it's not transparent and doing like gray background?
Trying to implement the text rendering, and I have some sample program in the main, and it's drawing the text, but it as well puts gray background, and can you help me to find out why it's not transparent and doing like gray background?
Can you help me to find out why it's not transparent and doing gray background? Okay, let's see if it's gonna fix the stuff. Pavif make. executable endless drive. Did we lose the internet? I think we still live. Trying to reach Gemini Flash, attempt 3, but what's going on? I do not know what's going on. So this changed, but it didn't do anything. So let me restart Gemini and give exactly same prompt. Write RGB. That's stupid, it's not going to do anything, but whatever. Do your thing. Free. What is it? No, I changed mine to render text in view free, isolating from the gray background in the geometry pass. Compile, we just make. God damn it. Gemini today is annoyingly Oh, it fixed. And I think the problem was with the render target. Because 0 and 1 was set to the texture, and this is what was causing the issue. Ah. Okay, so I think yeah, so these two lines should fix the issue. This one is not the source. Okay, let's go ahead. Yeah, we have render text. Do 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 do. Okay, let's take the break. Okay. Now I think I can delete all this distance field, drop shadow, font stuff, because I'm doing only basic font rendering. Let's delete all of this stuff. Let me as well delete data directory to make sure what I deleted is going to be deleted. So let's see if it's still rendering. Okay, so now it's crashing, and because I need to update the source code as well and load only one shader. Boom. So what next? What is DWIM? DD. Range unstaged stage work tree. Let's div work tree. Cube atlas. Cube atlas. Oh, there is a free type GL. Yeah, what is the implementation based on the article by Jones? 1,000 way to pick a bean. Okay, so what is this? The 1,000 way to pick the bean. Let's look. The 1,000 ways to pick a bean. Packing rectangulars it into bin with minimum number of beans. Oh, what? How am I supposed to read it?
We review several
pack the
algorithms
bean.
that can be used to solve the problem of packing rectangles into two-dimensional finite bins. Most of the presented algorithms have well been studied in literature, but some affidavits are less known, and some are apparently regarded as Faldor, and no previous reference is known. Different variants are presented and compared. The main contribution of this survey is an original classification of these variants from the viewpoint of solving the finite bin packing problem. This work focuses on empirical studies on the problem variant where rectangles are placed orthogonally and may be rotated by 90 degrees. Synthetic tests are used as the main benchmark, and solving a practical problem of generating texture atlases is used to test the real-world performance of each method. As a related contribution, an original proof conceding the number of maximal orthogonal rectangles inside a rectilinear polygon is presented.
Says the source code used in my survey 1,000 meters by practical approach to a two-dimensional rectangle. This can be used to solve the problem of packing.
The code can be used to solve the problem of packing a set of 2D rectangles into a larger bin. The algorithms are all approximations and use various heuristics since the problem itself is intractable. For more information, read the paper, which is also contained as a .pdf in this repository. The repository contains a build solution for Visual C++ plus 2010, is configured to build a single stat library of the algorithms. The preferred method of embedding these algorithms into your own code is to simply copy the code files into your own project and build them along your own build system. To use these algorithms in Python, you can make use of boost.python to enable interoperability between the C++ algorithms and your Python code. There are no build scripts for other platforms provided. For more information, see a series of blog posts at http://daemon.py/projects/rectangle-binpacking http://daemon.py/projects/more-rectangle-binpacking http://daemon.py/projects/even-more-rectangle-binpacking. The folder old / contains an implementation of the bin packing algorithm as originally presented by Jim Scott at http www.blackpond.com/text/lightmaps/. This implementation is only provided for historical purposes, since in practice, the guillotine method guillotine-binpack.cpp provides superior results in terms of performance and packing ratio, and also offers more configuration for variants of the algorithm. All the code is released to public domain. Patches and comments are welcome. It makes me happy to hear if someone finds the algorithms useful.
The link is there is a PDF. Okay. It's maybe nope. I do not know why I cannot select. Can I download PDF? Hey!
We review several algorithms that can be used to solve the problem of packing rectangles into two-dimensional night bins. Most of the presented algorithms have well been studied in literature, but some of the variants are less known, and some are apparently regarded as folklore, and no previous reference is known. Diarent variants are presented and compared. The main contribution of this survey is an original classification of these variants from the viewpoint of solving the night bin packing problem. This work focuses on empirical studies on the problem variant where rectangles are placed orthogonally and may be rotated by 90 degrees. Synthetic tests are used as the main benchmark, and solving a practical problem of generating texture atlases is used to test the real-world performance of each method. As a related contribution, an original proof concerning the number of maximal orthogonal rectangles inside a rectilinear polygon is presented. Keywords: two-dimensional bin packing optimization, heuristic algorithm, online algorithm, NP-hard.
Guillotine, best feed, guillotine. So from texture atlas from free type okay. GL by Nicholas the actual implementation based on article more precisely with implementation of skyline bottom left algorithm based skyline bottom left algorithm. Free type example for displaying a Unicode text using a single vertex buffer. The idea is simply to tightly pack every necessary glyph into a single texture and to generate a single vertex buffer. Code is very simple and organized as follows: vector, texture atlas, screenshots from an example. All links are broken. Okay, what it says, skyline bottom left. Skyline bottom left algorithm. Bottom left. Skyline bottom left. The skyline bottom left allows us to implement the same bottom left heuristic that the skyline algorithm.
The maximal rectangles algorithm involves some tedious manipulation to maintain the list of maximal free rectangles. We propose a simply ed data structure that can also be used to implement the bottom left heuristics. The data structure in the skyline algorithm is lossy, just like with the shelf algorithms. That is, it cannot perfectly keep track of the free areas of the bin and may mark some unused space as used. As a trade-off, the skyline algorithms produce packings a lot faster than the ones using the maximal rectangles data structure. The way the skyline data structure works is that it only maintains a list of the horizon or skyline edges formed by the topmost edges of already packed rectangles. This list is very simple to manage and grows linearly in the number of the rectangles already packed. Y et al. 13 describe a very similar method. In their approach, they call the skyline an envelope. The data structure is essentially the same, but the rule according to which they choose the placement position differs. The skyline data structure allows us to implement the same bottom left heuristics that the matrix BL does, except a bit of packing each and psi is traded for runtime performance. In skyline bottom left, we pack the rectangle R left aligned on top of that skyline level that results in the top side of R lie at the bottommost position.
I need
Since
to
R
read
can be
the
rotated, this might not be the skyline level that lies in the lowest position.
whole document. It's a 50 pages. I don't know. Let me start from beginning. Autofeed is 2. Yeah, this one is a bit good.
The two-dimensional rectangle bin packing is a classical problem in combinatorial optimization. In this problem, one is given a sequence of rectangles R1, R2, Rn. Rhi equals Y. High-end the task is to ND a packing of these items into a minimum number of bins of size W, H, No two rectangles may intersect or be contained inside one another. This problem has several real-world applications and is proven to be NP-hard 1 by a reduction from the two-partition problem 2. There does not even exist an asymptotic polynomial time approximation scheme aptas, but it is APX-hard 3. A lot of work has been done to develop efficient heuristic algorithms that approximate the optimal solution. In this survey, we present several of these algorithms and compare their performance on a practical level. By changing only a small rule in the heuristic decisions of an algorithm, one can obtain very different results in the produced packings. Most of the conducted research focuses on asymptotic performance ratios and typically neglects these subtleties since they don't usually play a role in the theoretical properties of the algorithm. We welcome these kinds of changes and test and practice how they affect the quality of the produced packings. The two-dimensional bin packing problem is a generalization of the one-dimensional bin packing problem, on which Csirik and Wojinger 4 give a good survey. The two-dimensional problem, there exist several variants. In one version, the process is modeled as if the rectangles are received from some input one at a time, and they must immediately be placed into one of the bins without any knowledge of the upcoming items. This variant is called online rectangle bin packing. The opposite to this variant is the O&E rectangle bin packing problem, in which the whole sequence to pack is known in advance. We examine algorithms for both variants. In one formulation of the bin packing problem, there may exist several simultaneously open bins, between which the algorithm can choose the destination for the current rectangle. In the more restricting variant, there's a limit on the number of bins that may be open at any given time, and to open a new one, an existing bin must be closed. The BNF algorithms we will present can be used for most restricting case where only one bin may be open at a time, but other variants exploit the case when there is no limit on the number of open bins. Packing is called orthogonal if all the sides of the place rectangles are parallel with the bin edges. We only consider packings that are orthogonal, and we allow that each rectangle may be rotated by 90 degrees. This is called rotatable rectangle bin packing. That is, the packing algorithm may choose. The two-dimensional rectangle bin packing is a classical problem in combinatorial optimization. In this problem, one is given a sequence of rectangles R1, R2, Rn. Rhi equals y. High-end the task is to ND a packing of these items into a minimum number of bins of size W, H. No two rectangles may intersect or be contained inside one another. This problem has several real-world applications and is proven to be NP-hard 1 by a reduction from the two-partition problem 2. There does not even exist an asymptotic polynomial time approximation scheme aptas, but it is APX-hard 3. A lot of work has been done to develop efficient heuristic algorithms that approximate the optimal solution. In this survey, we present several of these algorithms and compare their performance on a practical level. By changing only a small rule in the heuristic decisions of an algorithm, one can obtain very different results in the produced packings. Most of the conducted research focuses on asymptotic performance ratios and typically neglects these subtleties since they don't usually play a role in the theoretical properties of the algorithm. We welcome these kinds of changes and test and practice how they affect the quality of the produced packings. The two-dimensional bin packing problem is a generalization of the one-dimensional bin packing problem, on which Csirik and Wojinger 4 give a good survey. The two-dimensional problem, there exist several variants. In one version, the process is modeled as if the rectangles are received from some input one at a time, and they must immediately be placed into one of the bins without any knowledge of the upcoming items. This variant is called online rectangle bin packing. The opposite to this variant is the O&E rectangle bin packing problem, in which the whole sequence to pack is known in advance. We examine algorithms for both variants. In one formulation of the bin packing problem, there may exist several simultaneously open bins, between which the algorithm can choose the destination for the current rectangle. In the more restricting variant, there's a limit on the number of bins that may be open at any given time, and to open a new one, an existing bin must be closed. The BNF algorithms we will present can be used for most restricting case where only one bin may be open at a time, but other variants exploit the case when there is no limit on the number of open bins. Packing is called orthogonal if all the sides of the place rectangles are parallel with the bin edges. We only consider packings that are orthogonal, and we allow that each rectangle may be rotated by 90 degrees. This is called rotatable rectangle bin packing. That is, the packing algorithm may choose. The two-dimensional rectangle bin packing is a classical problem in combinatorial optimization.
What
in this
the
problem,
heck
one
is
given a
going on?
sequence of
Why it's
rectangles
repeat
R1, R2,
talking?
Rn. Rhi equals y. High-end the task is to ND a packing of these items into a minimum number of bins of size W, H. No two rectangles may intersect or be contained inside one another. This problem has several real-world applications and is proven to be NP-hard 1 by a reduction from the two-partition problem 2. There does not even exist an asymptotic polynomial time approximations. For an input R equals W, H whether to pack the rectangle R0 equals H, W instead. In some formulations of the bin packing problem, this is not allowed. This is not in any way a critical property for working of any of the heuristic methods, and each of them can be T to work for non-oriented rectangle bin packing case as well. In some real-world applications, it is required that the packings that are produced are guillotinable. Packing P is guillotinable if it can be split into two parts P1, P2 with a single straight horizontal or vertical cut that doesn't cross any of the rectangles in the packing, and where both P1 and P2 are either guillotinable as well or only consist of at most a single rectangle each. Not all of the algorithms presented in this survey produce guillotinable packings, but we make a mention of which do. Lodi, Martello, and Vigo 5 provide an overview and comparison of variance with and without guillotinability or rotatability properties. As a practical aspect, we can knee ourselves to solving the problem with all integral values. That is, the dimensions of the bin and the rectangles, as well as the coordinates on which the rectangles may be placed, must all be integers.
Must be integers.
In this chapter, we introduce each data structure and algorithm that was included in the review. These algorithms are classy ed in groups based on the underlying data structure that is used to represent the packing process and the free space left in the bin. We start with the easiest and then proceed to the more complicated ones. The shelf algorithms, or level algorithms, are unarguably the simplest methods one can use to produce packings. We delineate a shelf to a subrectangle of the bin with width WB and height HS. As the packing proceeds, the free area of the bin is organized into shelves, bottom up, in which the rectangles are placed from left to right. The last shelf, the topmost shelf, is called the open shelf. Since the rectangles are placed bottom up, the area above the open shelf is always unused. This allows that the height of the open shelf may be adjusted whenever a rectangle is placed on that shelf. The shelves below the open shelf, we don't have this freedom, and those are called closed shelves. When packing a rectangle W, H onto the shelf WB, HS, we have to choose whether we rotate the rectangle or not, that is, whether the rectangle is stored in upright store min WH, max WH, or sideways store max WH, min WH orientation. In all variants of our implementation, the choice is made in the following order. If the rectangle is the RST rectangle on a new open shelf, store it sideways. This is to minimize the height of the new shelf. If the rectangle TS upright, i.e. if max W, HHS, then store it so. Same to minimize the wasted surface area between the rectangle top side and the shelf ceiling. Otherwise, store the rectangle sideways if possible. The image 2.1 shows a sample packing produced by a shelf algorithm. The rectangles are numbered in the order they were placed in the bin, and the red lines show the shelf ceilings. All the variants of the shelf algorithm generate packings very similar to the one shown in this image.
I'm wondering why 3 is upright. If rectangle fits upright, then otherwise store the rectangle sideways. So it did not fit upright. If the rectangle is the first rectangle, is store it sideways. This minimizes the height of the new shell. 3 is wrong. Yeah, 3 is wrong.
Of all the algorithms and their variants presented in this paper, the shelf next fit is absolutely the simplest method to produce a packing. It has a special property that no other algorithm reviewed here shares, namely that it only requires a constant amount of work memory. As it will be seen, all other algorithms use some kind of data structure that is at least linear in the number of rectangles already packed. For shelf and F only.
Shelf next fit.
3 temporary registers are needed. This property may be useful in some applications. Unfortunately, the packings produced by shelf and F can be quite far from the best methods presented in the paper. It is somewhat wasteful to forget about the free space in the old shelves when a new shelf is opened. Therefore, all the variants of the shelf NF algorithm maintain a list of all the previously closed shelves so that rectangles can still be placed there if possible. But in case that there exists more than one shelf where the rectangle TS, which one should we pick? The policy in making this choice yields several variants. In shelf first fit, we always place the rectangle into the shelf with the lowest index where it TS. This is quite straightforward, but note that now both the running time and memory consumption of the algorithm is linear in the number of shelves in the current bin. With shelf FF, a rectangle that we manage to tee onto a closed shelf saves that space from being used in the open shelf. Compared to shelf NF, shelf FF can occasionally get a free lunch if it is able to pack a rectangle in this way. So one might think that shelf FF cannot perform worse than shelf NF, but this is not true. The reason is that since the packing decisions are heuristic in the RST place, it cannot be guaranteed that this smarter packing that shelf FF does would be any more optimal. In practice, shelf FF performed better than shelf NF, but for some sequences, it looks like shelf FF just hits a streak of bad luck when trying to outperform shelf NF and ends up with a worse packing. This E-act is a recurring one when comparing other algorithms as well. Proof. The additional ON space comes from having to store a data structure of the list of shelves, unlike in the shelf NF algorithm, where only the last shelf is kept track of. An implementation that NDS the RST shelf, where the rectangle TS by linear search, takes ON2 time, but with a bisection method, the shelf can also be found in log n time, thus giving ON log n time algorithm.
First, this is the one digraph, or what is it? And my text-to-speech do not understand it.
NDS. 1.3 shelf, best width fit shelf BWF. It can be seen as a shortcoming of shelf FF, that it doesn't consider all the possible shelves as whole, but just greedily places the rectangle onto the RSD shelf at TS. Perhaps it is better to RSD look at all the possible shelves, and only then pick a best one out of them. In shelf best width fit, we take a rule of choosing the shelf in which the remaining width of the shelf space is minimized. Since the edges dividing shelves are straight lines, packing a rectangle of smaller height than the shelf height just produces a strip of wasted space between the rectangle top side and the shelf ceiling. To minimize this wasted area, shelf best height fit chooses to pack each rectangle onto the shelf that minimizes the leftover height HSH. Both of the above methods have their advantages. To try to combine them, both we can try to maximize the total used shelf area. This results in the shelf best area fit algorithm. While shelf BWF tries to allow the width of each shelf as well as possible, the shelf worst width fit algorithm tries to do exactly the opposite and keep each shelf with as much width still available as possible. This is another curiosity with heuristic algorithms. Shelf WWF and shelf BWF are the total opposites of each other, but even still one cannot claim that one would be more optimal than the other. With shelf WWF, we adopt an extra rule that if we are packing a rectangle of width W and we ND a shelf that has exactly W units of space still left, we immediately pick that shelf to pack the rectangle in. Following the same pattern, one could deny the algorithm's shelf worst height fit and shelf worst area fit. But since the shelf algorithms waste the space between each pack rectangle and the shelf ceiling, trying to maximize this difference would correspond to maximizing wasted area, and therefore these variants are most likely suboptimal. If co-used with the floor ceiling variant or with the waste map improvement, see the next two sections that might not be strictly the case, but we did not test these variants nevertheless. Proposition 3. Each of the algorithms shelf BWF, shelf BHF, shelf BAF, shelf WWF can be implemented to run in ON2 time and ON space. Proof. For each rectangle to be packed, we examine each shelf to ND the best of them. The number of shelves has a growth rate of ON. All the above-mentioned variants still have the same problem, that they cannot recover the free area that they waste when the rectangle heights do not match the height of the shelf. To fix this, Lodi, Martello, and Vigo 6 proposed the shelf floor-ceiling variant, where the input is sorted by decreasing longside RSD, and is packed normally into shelves proceeding left to right along the or of the shelf. As soon as we close a shelf, and thus X the height of that shelf, we also start packing rectangles from right to left along the shelf ceiling. Since the input is sorted by decreasing height, trying valid ceiling positions to place the rectangles into is feasible by using a simple data structure. The authors show that this improves the performance of the shelf algorithm. We did not implement the shelf floor ceiling, mostly because we feel that it is quite similar to and probably outperformed by the Skyline algorithm, but we cannot verify this claim.
Yeah, anyways. So, Cube Atlas essentially is the packing algorithm. Texture size, add region, width height, bitmap buffer. And I guess it returns something. Update, pre-allocated region. Pack UV. Oh, so it returns region handle. So vertex buffer, and it populates pack UV. Turn the texture handle, retrieve a region in 4, texture size, region count. Okay, Cube Atlas. Font basic font. Texture cube. So it's texture cube, I guess. It's a function which probably in the shared lib. Where it's coming from? Ah, okay, so there is a BGFX shader. I don't know. Sampler cube. I'm wondering what code it would generate. Ah, sampler cube. Okay. Font manager. True type handle. Font handle. Create font by pixel size. I do not know why it was done this way. I believe this license is MIT license, right? BSD2 clause. Redistribution source code must retain the above copyright. In binary form must reproduce the above copyright notice. Yeah. I like more MIT that I don't need to give attribution, but it's and I don't, because I need to keep track if I'm using a lot of libraries. Have to keep track, a lot of assets have to keep track, and sometimes I may forget, and I just don't want to accidentally, you know, not comply with the license. So what is the font? This is the font manager. So create TTF, create font by pixel size. New true font. Scaled font to pixel size. Destroy font, preload glyphs. $2400, 200. Find glyph. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I assume it's Reels. Let's put font to here and remove this one. Hey, Yogi. Font manager. Text buffer manager. Text buffer manager. You know, we made some progress. I'm going to quit the stream. Okay, I'm going to commit all these changes. So all this code requires some massaging, but there is a lot of code. And as well understanding what's going on here. So yeah, work in progress, text rendering.
WIP text rendering.
Okay, so I will continue with the text rendering. Need to figure out the way to make it ergonomic and prevent mistakes what I was making. So implementing RAII for all this stuff. And yeah, just reading the code and trying to understand if I can cut some corners, or understand if there is some waste and bunch of boilerplate code. So there is a font manager, text buffer manager, font file, font. So not sure if we do need to do all this thing. Preload glyphs. It's like why I would think preload glyphs, but if glyph is not existing, probably we should maybe create them. So on the fly, this sort of tuning and how to move all this stuff from main file to some other classes. We already got bunch of classes. There is a font variant, and maybe I can combine this font variant with variant. There is a position back free, right? Maybe I can make it here back free. I'm wondering how does it work, huh? Oh, it says there is a position 0 and just a position. V color 0, V color 1. And I'm not passing colors here. Anyways, thank you for watching, and hopefully see you next time. Bye.